Hey everybody, I am MA, and with me I have Mahan, and we're going to host this live today. This is our second live on the very basics of IoT. When you think about IoT, you think about these devices that are connected directly with the internet. This internet connectivity gives them the ability. Technically gives you the ability to be able to control them or monitor them from anywhere you are. And this is exactly what comes to mind when you think about IoT. You can either monitor your devices or you can control them from wherever, literally wherever you are, since they are connected with the same internet as your mobile devices are, right? So in our last session, we talked about how you can monitor, you connect your devices online, bring them online, and monitor them from wherever you are. In this session is all about control, how you can
Control your devices.
control your devices. So let's start. Let me share my screen.
So this is essentially where Granger Canvas comes into play.
Can you share my screen?
I can see your screen. Yes.
Yes, perfect. Okay, so why would we want to control our devices? What is the specialty? What is the use cases that come into your mind when you want to think about controlling your devices over the internet? There are a lot of things. I have written some of the most basic ones here. You might want to play with the lights of your room or the air conditioning of your room. We all have used RC cars, right? They have a range of a couple of 100 meters. But let's say you mount a camera on an RC car and give it an internet connection. You can literally extend its range to an infinite range. You could be, let's say you are on a vacation and you have nobody to take care of your plants in your office. Totally, I and Maham can relate. So
Yes.
you can
My
water your
plant is still
plants
alive though.
anytime you want. Yeah,
Mine is still alive.
mine is not. I went on a 2 weeks vacation. That was 2 weeks vacation, and I'm trying to revive it though. Anyways, you let's say you are out in your office and you have unsuspected guests at your home. You can open your house for them remotely from your office. Let's say you are in a hurry and you leave your home and you are on the road and you just remember that you forgot to turn off any appliance, for example your fan or ACs. You can turn them off from the road. So these are just the smallest use cases that I could come up with, but there obviously can be uh, similar use cases. Control is everywhere, but there can be bigger use cases that happen on a much larger scale, because obviously monitoring and control are the most basic things that anybody could want. So let's dive into how we can actually control our devices. So today we are going to use an ESP32. I don't think I need to explain what is it, but how it works. It's just a microcontroller. It's just a microcontroller that has a Wi-Fi chip built on it, so it can legit connect with the Wi-Fi. So what we'll do today is we'll first connect ESP32 with Wi-Fi, and then we'll connect it with the internet. And for that, we will use Ranger.dev. It's an Let's just open a browser window. Oh, it's already. Yeah, can I open a new one? Yes. So, Granger is an IoT platform that makes it extremely simple to connect your devices with the internet, monitor them, or control them from wherever you are. It also gives you drag and drop. It also lets you build drag and drop dashboards or apps, so for you to be able to monitor them legit and control them like this. So we'll use we'll use Granger today. We'll see how we can use it, and we'll use Granger CLI to upload our codes to our ESP32, because Granger CLI integrates perfectly with Granger. It automatically handles the dependencies and libraries for whatever you need to program your devices. So let's dive into it. Let's dive into the main stuff. Open Uh, let's open a new folder for our sketch. I'll create it on the
CLI?
desktop. I'll just open it in a terminal, and I'll use Granger and Net. to create a new sketch. I'll call it, since we are going to talk about control, let's create an internet switch. It's an internet switch is something, it's just a normal switch that is connected over the internet. So you can literally switch on or off anything using that. We are since going to use an ESP32. So select the architecture and it's done. We have a sketch created. I'll go to my desktop and should have an internet switch folder here open in VS Code. There's a lot of clutter on my desktop. Sorry for that. So when we create a new sketch, Cringer CLI, we have two files in it. One is the main INO file that we'll write our code in, and the other is package.json. Package.json just contains all of the specifications of the sketch, like its name, version, the main file, and the dependencies. That is why this is exactly what Granger CLI helps in. It automatically installs the necessary dependencies. Like we're going to use Granger library to connect with Granger, so it does that. And last thing is just architecture, is we're going using an ESP32. So let's write some code. Since we are using Granger, I just include its library, and we are going to connect our ESP32 with the Wi-Fi. So I'll import that as well. Now to connect with Wi-Fi, we need SSID and variable, SSID and passphrase.
Passphrase.
So I'll just create variables for them, and I'll put in my Wi-Fi information. Passphrase. There we go.
Password always gets me.
Let's create a function to connect with Wi-Fi, and we'll call it in our setup. So once our device reboots, it automatically connects with the Wi-Fi. We'll first disconnect. If our device is already connected with some Wi-Fi, it first disconnects, then it starts searching and connecting with the given Wi-Fi. I'll create these params. There we go. Then we wait for until the Wi-Fi isn't connected. Wait. That's wrong. While we're waiting, while it's waiting to connect with the Wi-Fi, it should, you can print dots and add a delay, so it doesn't start printing dots indefinitely and like 100 dots in a second.
So right now we're printing dots every second.
Yes, we're printing dots every second because we have this second delay, 1000 milliseconds technically. Okay, so once it's connected with Wi-Fi, it exits this while loop and we print. We can print its IP address and connected with Wi-Fi. Or we probably don't need an IP address. It's just something that everybody does. So just skip it. And we can also know that it had started connecting with Wi-Fi. We'll just print something here as well. Connecting with using this passphrase. So here we have our connect Wi-Fi function. We'll call it in setup, and when our device boots up, it connects with this Wi-Fi using these SSID and passphrases, right? So now once our device is connected with the Wi-Fi, we need it to connect with the internet. That is where Granger comes in. So for that, we first call this initialization function. So Granger.init is a function that the library automatically gives you. Pass. You can with using this, you can initialize your library, give it all the configurations. So there are mainly. Let's come to this part of coding, how we can give the configurations list. let's first create our project. Since I previously told you we need to connect with Granger, we need a project at granger.dev, right? So let's just go to, just open a new window and go to granger.dev and click on login, and it takes us to not
Console.
granger.dev. I need to go to console.granger.dev. Okay, so I already have a project. You might not have, so I'm just going to restart the whole process. So once you land on console.treasure.app, this you land on the login page. You can create, if you do not have a new account, you can create one by filling this form and clicking on submit. I'll just go to login, and once I log in, once you log in, this is the home page where you land. I already have a project, but if your account is new, you might not have one. So you can create a new project by clicking on new project. You can call it, since we're making an internet switch, we'll call it internet switch. Uh, which is anything on just a friendly description over the internet. Okay, so we have our project ready. So this is the this is the home tab. We have all of these resources. This projects that you can build, that you can get some help from. We have docs and we have Hackster. Uh, the other two important tabs, technically three important tabs, are this. One is this devices tab. This is where we register our device. We'll come to that. This is the canvas, the drag and drop app builder that we'll use to control our devices. And this is the second settings tab, where all of the things and configurations about our project are stored. Right. So first of all, we need to focus on this API key. So API key is something that automatically gets generated when you create a new project. API key is literally a unique identifier for your project. It tells which project you want to connect to. And one, we should probably should copy this API key. We'll need it later on. Let's just create a variable, paste it here. We'll see how we use it. We'll go first API key. Then, since we want to connect our ESP32 with the internet, we need to register it with Granger. When we register it with Granger, it creates a digital copy of this device. It works like this. Uh, you update the data in your digital copy and automatically gets propagated to your actual physical device. So to register a device with Granger, we need to click on add device. It asks for a model. We do not have any models available. So let's just create a model. A model is something that I'll explain once I create this. I'll just call it an internet switch. Just call it internet switch as well. Explain why. And create a schema. So this is the name of the model. This is a schema of the model. A scheme. So a model is something. Uh, in a programming language, let's say the same way you create a class, a model is like a class. It's the blueprint of your devices. By blueprint, I mean the you you say what kind of data your device will have, what kind of schema, the same thing, what kind of schema your device is going to have. You create a model for that. So once I add a model, it creates this, and I can register my devices based on this model. So you can have three or four models that describe what kind of devices you have in your project. For example, in my case, I only have one internet switch, and you can then create as many internet switches as you want using this model. So a model is like a class, devices are like an objects of those class, like instances, right? So I'll add my device using this model, internet switch model. We call it, let's say, just call it switch. It's my first switch, so switch 001. So when I add a new device, I get three keys. The switch 001, the name that I just gave my device, I get this device ID. It's a unique identifier for my device, and this is the device token. Device token is a secret, a key, a pass that the device exchanges when it's trying to connect with the internet, right? So when you want your device to connect with the internet, there are technically three things that the device sends to Ranger that verifies that it's a legit device. One is the API key. It tells Ranger what project you want to connect to. The second is this device ID. It tells Granger what device you are, and then the third thing is this token, which is just a password, a passphrase, or a secret, whatever you want to call it. So let's just copy these two things as well. We already have the API key. Copy device ID. We have this. We do not need this space, and we need a token. The token, this token. Copy this, and we paste it here. So now we have all three things that we need. We'll go to granger.init and we'll pass that API key and token. This library that gives the library the API key and token, and this function returns an instance of a project. To save that instance, we need to create a new variable. So there are two helper variables that the library gives you. One is Granger double colon project, and the other is Granger double colon project device. Right? So we have these two variables. Granger.init returns a project that we save in this variable, and then we can do project.device and pass it our device ID. It returns an instance, a reference to our device. We can save it in device. Now, so we have configured our library. So once our device boots, it first connects with Wi-Fi, then it starts connecting with the internet with Granger using the API key token and this device ID. So once it's connected with the internet, we need to uh, we need to we need to control this device, right? So there are three kind of helper functions that the library provides for you to interact with the device. One is data.get, other is the same but device.set, and the third one is on. Yes, on. So they do the same as their name describes. Get is when you want to get data from the internet, you use device.data.get. When you want to send data to the internet, you use device.data.set. And when you want to, so on is like
Subscribing to a particular variable where you don't want to get information again and again, and you just want to know what change has been made when it's made. So
yes,
on is like that, where you
yes.
want
If you
the
work
device
in
to tell you.
MQTT,
Okay, you can continue.
uh, okay. So if you're worked on MQTT, you know how the publish subscribe method works. It's the same thing. You can subscribe to a variable or something. You can subscribe to a device data, and whenever a change occurs in that data, it sends you the update. It notifies you. So for this, our device is going to subscribe to its data in the digital copy. So whenever something, a user or some app or some dashboard changes that data, this device gets, our physical device gets notified that the data is changed, so it can change its own state. Right? So for this internet switch, we do not need get or set. We'll just go with on, and we'll subscribe to the status variable because that is the variable we created in our model, the status variable. So when the status variable changes its state, its value, our device changes, turns on or off its LED based on that state. Right? So I'll just subscribe to status, and whenever the status is changed, I call a function called update LED. So I just update LED. I can create this function up here, a callback function, which means you pass this function to another function. So the library saves this function for later, and whenever it receives an update on status, it calls this function automatically. And when it calls this function, it passes that two things: path, technically the name of the variable that is being updated, and the actual update that occurred, the actual new value. So what we can do anything with the new value. We can rent it, rent update is update. So we print the update, and we can use the update to change the state of the LED. For that, we do digital write, and since we are going to change turn or on or off the LED, we'll use
This is where we control the built-in
LED.
LED of our ESP32 module.
Yes. So we'll send this update to the LED. Since it's a string, so we convert it to an integer by using a to I. So let's say whenever if the update we save is 0, it turns off the LED, and if the update is 1, it turns on the LED. So it's technically just a boolean value. Now, so when so, so we have created our callback function. What else we do? We need. I think that's it. The last thing, the most important thing, is this project dot loop function.
Without which nothing will work.
Yes. Without calling this function, the SDK, the library just won't work. Nothing will work. Your device will not connect to the internet. Your device will not get any updates or be able to send any updates to the internet. It just what it does is it just flushes the network buffers. So any data that you want to send gets sent, and any data that you are to receive, it receives it. It's just something that you need to call in your loop function, right? Okay. One last thing, I think since I'm going to turn on or off the LED. I need to define its pin mode. Define it to output. Right. I guess let's run it.
Let's try our luck with the first take.
Try luck. We call range.run. It runs our code. By that I mean it first compiles our code, and then it uploads it to the device, and then automatically can open serial monitor. Connecting the board. Run. Let's see. Okay, so it's asking for what device I want to upload it to. So if you're running it for the first time, you will not see the first two lines. You will just only see these last two lines. It asks for a port because it doesn't know what kind of device you're connecting to. So you can just select this port, and it asks you what kind of device you have. You can go to ESP32. I'm going to use DevKit1. Once I'll use that, and once you do it once, then every time you call it again, we call it ranger.run. It already knows what device you have, so it gives you the options that I had just. So compilation started, so we have a lot of errors. What errors?
Okay,
nice. Nice. That's a lot of errors. Connect Wi-Fi. No matching function call to hardware serial print line. What did I pass? What did I connect Wi-Fi? We have serial.print line. Oh, okay, right. So this should have been printf. This just reminded me of another thing. We did not do serial dot begin. The software, the serial monitor not work without it. Do it again. Ranger run. See, we have our device saved. No.
And our fingers crossed.
Fingers crossed, yeah. Okay, so we have a couple of warnings that are probably coming in from some libraries. We can ignore them for now. At least we do not have them errors. So it compiles, so it works. Good for us. Now it should start uploading the code to the device. I'll press the IO pin on my ESP32 so it can upload the code. And then it's opening the serial monitor, connecting with the Wi-Fi. It's connected with Wi-Fi. Now it's trying to connect with the internet. there is something, there is another function we that the library provides that you can use to know if your device is connected with the internet or not, right? We call it, is should I it's project dot on connection. So when your device connects or disconnects with the Wi-Fi, this function tells you that it receives again a callback function. I just call it on connection handler and I'll define the function here. The library calls this function with boolean status variable. We can use a switch case on this status to do whatever we want to do with it. We can use two values connected and disconnected. Can print connected with the internet. We break it and just copy paste it here and we can do disconnected from internet. Let's let's run it again. Compiling. Connecting. Seeing the IO pin again. So putting the code. So this time, when our device connects with or disconnects with the internet, it will tell us Wi-Fi connected. So, so our device is connected with the internet. So the next thing is to control our device, right? So for that we will go to back to our browser window and go to canvas, and here we can make our app. We'll open add widgets and we have all of these widgets that we can use to do whatever we want with the device. For this internet switch I will drop a button
Because we
drag it
essentially have to turn it
yeah.
on and off, and what's better than a button for that?
Yes, I'll call it a switch, obviously. And since we're using a status variable, so we'll just update this variable to 0 and 1. And when this value is sent to the ESP32, the update LED function will turn on or off the LED based on that value, right? So we'll run it and it says no pair devices. Nice. Let's go back to our devices tab. We need to, so there is something that we need to do. Our device does not, so to control or monitor our devices from anywhere, we need a user, right? A user is just an entity that can interact with the devices. So for that, first we go to accounts and we can create a user using the add account. We can call it anything. We have put in the email and password and a phone number. Just random for now. I'll add it, and so we have a new user. And I'll go to device and pair this device with the user's pairing. Technically, just gives access to this user to
So essentially, this user
create.
just gains control of this particular device, because you do need someone to control whatever you're
Yes.
creating.
Now when we run it, we get this device, right? So we have our app running. We can switch on or off our app from this switch, and as you can see on the device, it should blink on or off. Is it blinking?
It is.
It is?
Yes.
Yeah, that works then. Okay, so this is it for this coding jam. If you can also do,
We can also show it on our serial monitor just like we did.
yes, we
So
can show. Yeah.
yes, all the
So since
updates are
we
over
are
there.
printing the state, once I can do something. I can drag it here, and I can also drag this
Hmm.
just for just to show
And
how it
that
works.
will
So
give you better visualization of whatever we're talking about.
yes.
So
So
yes.
I'll place them in the same desktop. I could close this window and I'll make this terminal big. So when I turn this on,
You see that
up,
we have.
you see update is one, and when it's off, it goes. And simultaneously, the LED turns on and off as well. Right. So you can control. You can also in the last live session we saw how you can. Uh,
Create and bring a device online, and in this session what we've done is essentially control that device through our canvas.
yes. We have all of these other widgets display that we used last time to monitor our devices. We have graph and we have a table where we can just see the data in a list format. We also have a progress and we have a slider. For example, let's say you want to control the brightness of your lights, of your LED, whatever you want. Right. So all of these widgets, you can also Granger also gives you APIs. Using them, you can. So you are not limited by the tech of Granger's own tech and whatever it gives you. You are not limited by that. You can make your own apps using any language, and you can control your devices through these variables. I mean, you whatever you want to do with your device, you do through these variables. You change their value. You can monitor these variables by viewing these. You can monitor your devices by monitoring these variables. You can control your devices by updating these variables, and anything you can do. Right. So we'll this is it for this live. We'll do another one soon. We'll see how we can use the APIs to control or monitor devices using an app in
For
the
that
next
we'll
live
be
session.
going towards our JSSTK. So right now we've showed you how to control our devices through our canvas, and next time we go live we'll show you how to do it through our JSSTK. So that's going to be an interesting ride where we build an app together.
Yes. So this is it for now. So I'll see you next time we go live.
Bye.
Stay tuned. Bye.